Hi everyone and welcome to our CSI or Crime Scene Investigation assignment. So the source of the assignment is right over here and I've just adapted it a little bit to suit our needs. Okay, so here's the scenario. All of the field trip money at the school has been stolen, but there has been a little bit of evidence left behind. Okay, so first of all, there were two footprints or a set of footprints that measured 65 centimeters apart. There was also a jacket with an arm span from here to here, okay, an arm span of 153 centimeters. So based on this information, we're going to collect some data on the heights of people and then their arm span and their stride length. And we're going to try to predict how tall we think the suspect is. Okay, so we're going to be focusing in on the height of the person, how tall they are, but also two other statistics, okay, or two other variables, stride length, and also the arm span from wrist to wrist, okay? So I want you to grab a measuring tape or one of those flexible measuring tapes or even a meter stick, okay? And you're gonna collect some data about the height, the arm span, and then also the stride length of, let's just say about 10 different people. So feel free to get your own data. Also get your teacher's data, maybe some classmates, maybe some family members, whatever, whoever you have around you, okay? And then based on that, we're going to create a scatter plot using the height versus stride length and then the height versus the arm span, okay? And we're going to predict if we had the specific data of the arm span and the stride length, and we're going to predict the height, okay? And then from there, we're also going to try to figure out which one is the best predictor, okay? So please collect that data, and then we're going to throw the numbers into Google Sheets, and we're going to let the software do the calculations for us to figure out the line of best fit. Okay, so I hope you've collected your data, and I'm going to introduce you now to Google Sheets, if any of you are not familiar with this, okay? So it's an online graphing tool. It's part of the Google suite of tools. It's for free on all the Chromebooks and stuff like that, okay? And like an online graphing tool is really valuable because it's often required on science lab reports and you want things to look professional, okay? Also, whenever we're doing the line of best fit with like the slope and then we're trying to mathematically model with using a formula, the programs that are embedded in these graphing softwares, such as Google Sheets or Excel, Microsoft Excel, okay, they are much more accurate and we don't have to like eyeball the results, okay? So let's just pretend that we have this data, okay? So you had your own data, but I'm gonna use some data that I've collected myself, okay? You're gonna get different data, okay? And so we're going to copy and paste. You can actually just grab the data and you can enter it, right into the table that's available right there, okay? So you can enter it in. That way your teacher can see the data. And then we're going to open up a new tab and we're going to go to Sheets and we're going to create a new blank document, okay? So I've renamed and titled my file CSI Graphing, and then I'm going to Control V to paste. And just a little tip, okay, you can go to the top when it turns into like the double arrow. If you double click, so double click and double click right at the top when it turns to that double arrow, the width of the cell automatically expands to like the longest word length, okay? Okay, so we are going to graph this data. We're going to create two separate graphs and we want to be able to predict the height based on the stride, okay? So the height should be the dependent variable, and we know that the dependent variable is usually on the y-axis. So I'm just going to reorganize my table of values just to make my life easier so I don't have to mess around too much with the settings on the graphing tools. Okay, so I'm going to actually, right at the column heading, I'm going to right click. So I'm going to right click and I'm going to insert a column to the right. Okay, right over here, okay? And then I'm going to select this whole column. I'm going to Control X or cut it, and then I'm going to paste it right here, okay? And I'm going to do the same thing. I'm going to paste again the height information right over here as well. Oops. Paste. Okay, I got to do this again. Control C, Control V. Okay, so now we're going to insert the chart, okay, or insert the graph. So we've got stride length and height, and I would recommend that you do that in that order, okay? we're going to select the data, including the headings, and we're going to go Insert, Chart. Okay, so it has this information right over here, and we're definitely seeing that there's a trend, right? If I were to like kind of make a line of best fit going through all this data, it would have a line that's a little bit sloped, not very steep, okay? Let's actually put in the actual line and let the program predict what the line should be. Okay, so when we're doing a line of best fit by hand, like graphing by pencil and paper, we would normally have to guess at how steep the line is supposed to be. But when we go to customize, and then I click on series, and then I scroll down, and I click on trend line, they actually will automatically put in the line. They think it's linear, okay, right over here, but there are some different options. But this line looks quite straight. Exponential means it's curved, like it looks like a slide, okay? But ours looks like it's pretty linear. It follows a straight line pattern, so I'm going to stick with linear. And in addition to this, where it says label, I'm just going to choose use equation, okay? And this is actually a mathematical model, okay? So when I have a given stride length, which is my x variable, so for example, if I had 70 centimeters as the footprint length, okay, from one footprint to the next footprint. If I had, for example, 70, if I put that number 70 into here and multiply it by 2.72, and then I subtract 15.5, that actually gives me a mathematical model to predict what the height of that person will be, even though I've never met the person. Okay, so this is why mathematical models are really valuable, because you can use them to predict based on the formula that you've established. Okay, next up, we're going to move this out of the way. I'm just going to move this to the bottom here. Okay, and then we're going to do the same thing, but for arm span versus height now. Okay, so I'm going to do the same thing and then make the chart. Okay, so for this graph of height versus arm span, again, if we know what the arm span of someone is, we can predict what the height is by using this trend line, and we know this equation, okay? So our problem was asking us to predict for the suspect who had an arm span of 153 centimeters and a stride length of 65 centimeters. So we're going to try to figure out how tall this suspect was. So now I've taken my two graphs and I've just put them side by side. And we know that we're looking for a suspect with an arm span of 153 centimeters and a stride length of 65 centimeters, okay? So what we're going to do is we can like look this up over here, okay? So if we're looking for 153, this would be like 152.5, right? So like maybe right around here, we would go all the way up to get to the line of best fit, and then we would go across. Okay, so we're like looking at somewhere around here, okay, right over here, but it's pretty difficult to see from our graph, okay? So same thing over here, stride length of 65, so 65 would be like halfway point right over here. Okay, so like right over here and then going across. So again, we would have to like estimate, and this is where, for example, graphing by hand is very inaccurate. Okay, so this is 65 and this is 153, okay? But let's use instead the equation, the formula that has been provided, okay, from the Sheets program. Okay, so we're going to use both of these in order to predict the numbers. Okay, so we're going to take this equation that I got over here, okay, and in place of the x, I'm going to put 153, okay? So we're going to figure out what the height is, the h, by going 8.834 times x. So I'm going to take out the x, substitute it with a value, but I'm going to recopy everything that's around, okay? And my value that I'm going to put into here is this value right over here, 153, okay? So when I do 0.834 times 153, I get 127.602. I'm going to add 41.7, and then my final answer is 169.302, okay? Now I'm going to round that to the nearest centimeter, so I'm going to cut off at 169, and I'm going to look and see if that's enough to push it up. It's not, So we're going to round it to approximately 169 centimeters, okay? Next, I'm going to do the same thing with this one, but instead, it's going to be the x is going to be the stride length. So my x is going to be 65 centimeters, and I'm going to be substituting right into here. Okay, so I'm going to predict my height using stride length, but I have a different value for the stride length. I'm going to put the x, I'm going to substitute, take out the x, put in a set of brackets because I'm going to be substituting, and I'm going to be minusing 15.5, but in place of my x, I have 65. Okay, so when I work that out, 2.72 times 65 is 176.8. From there, I'm going to minus the 15.5, and then my final answer is 161.3, and then we're going to round it, okay, so to the nearest. Okay, so again, this 3 is not enough to push it up, so I'm going to round it to 161 centimeters, okay? So you'll notice that I did not get one exact number. Instead, I got two different numbers. I got that based on the arm span, we might predict that this person is 169 centimeters tall. But based on the stride length, we might predict that this person is a little bit shorter, 161 centimeters, okay? So you might come up with one number or a range of values, whatever is reasonable, and then just write down what your assumptions or the reasoning for why you chose that one number or range of values, okay? And then submit that to the teacher. Okay, thanks everyone, bye.